Welcome back everyone to this lecture on like and I like. And really it's more than just these two keywords. This lecture is about using pattern matching with string data. We've already been able to perform direct comparisons against strings, such as where first name is equal to John. But what happens if we want to match against a general pattern in a string? That enables us to answer questions such as all emails ending in @gmail.com, or all names that begin with a capital A. The like operator allows us to perform pattern matching against string data with the use of special wildcard characters. So there's two main wildcard characters we're going to cover right now, and that is the %sign, which matches any sequence of characters, so essentially any number of characters, and then there's the underscore, which matches any single character, essentially a wildcard for just a single character inside of a string. So let's see a couple of examples of this. We'll start off with the %sign. So the %sign is a wildcard character for any sequence of letters or characters. So this basically specifies something like all names that begin with a capital A. So we would say where name, like, and then a string where we have the capital A and then the %sign, essentially saying you'll match with anything that starts with a capital A and then has any number of sequence of characters after it. Then we could do something like all names that end with a lowercase a. So then we have where name, like, and then we start off with the %sign and end with a lowercase a, essentially saying that anything or any sequence of characters can come before that lowercase a. Notice I've been saying things like uppercase or lowercase, and that's because like is case sensitive. However, you can always use I like, which is going to be case insensitive. Now using the underscore allows us to replace just a single character. For example, let's imagine we were storing the Mission Impossible films and they were titled something like Mission Space Impossible Space and then 1, 2, 3, or 4, etc. So we could do something like where title like and then Mission Impossible space and then the underscore just leaves a single wildcard place to fill in whatever number we're looking for. Now you can use multiple underscores. So imagine we had a version string codes in the format, something like version, numerical or hashtag A4, and then version, hashtag B7, etc. So that would be something like where value, like, version hashtag, and then two underscores, where those two underscores can be filled with any sort of characters you want. So this essentially leaves open any two characters to fill in those specific underscore positions. Now what's nice about this is then we can begin to combine pattern matching operators to create more complex patterns. So take a look at this example where we say where name, like, and then underscore HER %sign. So if we think about what this is actually asking for, this is returning back, and we've color coded it here, a single wildcard space for the first letter. And then after HER, any sequence or any number of characters can occur. So here we have Cheryl, which starts with a single C, then HER, and then has two characters after that. Or Teresa, which has a capital T, HER, and then ESA. So notice here, it has to be just one character before HER, but then any number of characters after it. So this allows for really powerful pattern matching code. Now we're just focusing on like and I like, and those two wildcards of an underscore and a %sign. But in case you're familiar with something called regular expression or regex in other languages, such as Python or C++, I want you to keep in mind that PostgreSQL actually does support these full regular expression capabilities, and you can check out the link here, or just go to the docs and look up functions matching. And not only does it have information on like and I like, but it also goes into much more detail on regular expressions. We're not going to cover those for right now. Instead, we'll just focus on like and I like. Let's check out some examples in pgadmin on our own DVD rental database. Okay, here we are at the query editor. Let's imagine I wanted to figure out how many people actually have a name that starts with J. Well, I could say select, and we'll start off by selecting everything from the customer table, and we're going to check where their first name is like, and then notice here I'm going to say capital J and then %sign. And then if I run this, I get back the results for everyone that has a first name that starts with the letter J. And if I wanted to actually figure out how many of these there were, I could simply just provide a count on the number of rows returned, and I get back there's 65 people who have the first name that starts with the letter J. Now I can keep adding on to this, so then I could say something like, and last name like, and let's go ahead and do something such as starts with an S. And I'm not actually sure if there's someone like this, but we can run this and check. Okay, looks like there's 5 people. Let's go ahead and explore those names. So just grab all those rows for those customers, run them, and here we can see there's Julie Sanchez, Jeffrey Spear, etc. Okay, so that's how it worked for the %sign. And notice here that I had to make sure to use capital J because I'm using like. If I were to lowercase one of these and run this again, I get back nothing because this is case sensitive. Alternatively, if I don't want to worry about case, I can use I like, run this, and it'll return back the results. Whoops, accidentally changed this to J. Let's go ahead and change that back to S. Run that again. Okay, so there we go. I like is case insensitive, which means it doesn't matter if I use the lowercase j here or a capital J and a capital S. I run this again, it's going to be the same result either way. So I like is case insensitive, like is case sensitive, just something to keep in mind. And we can always add in more than just a single wildcard character. For example, we could do something like this. I can say first name, like, and let's imagine I wanted to figure out people who have the sequence of characters ER somewhere in their name. So I could do something like %, ER, %. I run that. And basically what that's asking for is anyone who has ER somewhere in their first name. Now notice it'll return something back like Jennifer. So ER is at the end of Jennifer, and this sequence of characters can also be nothing. It can be 0. So that means ER just has to show up anywhere inside this name. So Kimberly has the ER here in the middle, Catherine does as well, but something like Heather has it at the end, and that still is okay with this sort of code. So just because it has a % doesn't mean it has to fill in something there. It can be blank. And we can keep doing this. Maybe we want something like her somewhere in the name. Run that, and I can see Catherine, Heather, etc. Or we can do what we did in the slides, which is replace one of these with a single underscore, which means only one character is now allowed in that space. So now when I run this, I only see back Cheryl, Teresa, Sherry, and Sherry with an I. So note the difference here is now only one character is allowed before this HER. Something that's also important to note, and we'll finish this off, is to show you that you can also add in the not operator to essentially get the opposite. So I can say, give me everything that's not like this, essentially everyone that isn't these 4 people. So I can just run this, and here I see everyone that wasn't in that list of 4 people. We then can combine this with things like logical operators such as AND. So I could do something like, let's say we're first name, like, and let's say it has to start with an A. So we go ahead and run this, and we can see everyone whose first name starts with an A, and let's go ahead and order it by the last name. So we can start kind of getting more complicated here. Order by last name, run this, and now I can see Alma Austin, Angel Barkley, Agnes Bishop, etc. But let's imagine for some reason I didn't want anyone whose last name started with a B. So I wanted to remove Barkley, Bishop, Bradley, Burns, and Butterfield here. Well, I can begin adding things. So where first name is like A, and then we can say something like, and last name not like, and then we'll say starts with a B. So we go ahead and run this, and now I can see I got rid of those people that had a last name that started with a B, and yet retained everyone who has a first name that starts with an A. So you can begin to create really custom patterns for whatever you're looking for with just these wildcards. So keep in mind you always have the % and the underscore available to you. % for a long sequence of characters, underscore just for a single replacement character. All right, thanks, and we'll see you at the next lecture.